So if you're given three sides of a triangle and you're being asked to find what are their angle measures, or even just what's one of the angle measures, you can use law of cosines for that as well. Okay, so if I were to once again sketch what I have here, triangle ABC, I have side lengths. A is 65, B is 51, C is 71. Now, when you use the inverse cosine to find angles, which is what you'll do from law of cosines, when you do your calculation on the inverse cosine, do cosines repeat values between 0 and 180 degrees? Are there any angles from 0 to 180 that have the same cosine? No, right? It goes from positives to negatives. Okay? So when you use inverse cosines, it will distinguish between obtuse and acute angles. Okay? So if I'm given a problem like this, and I know I'm going to use law of cosines to find it, and I don't ever want to find the largest possible angle using law of sines, which of these angles should I find first in this problem? I want to find the largest angle first for cosines. Okay, so law of cosines, I can find any of them. Okay, you can find any. It's going to work no matter what you choose, as long as your law of sines rule applies that you're not finding the larger of the remaining ones. You're good, or the largest of all of them. But I would just go ahead and make sure I find the largest one first. So I'm going to find C first here. So my law of sine or cosines is my unknown is going to start at the extremes, either the very beginning or the very end. With this pattern, it's going to be my angle at the very end, so I'm going to start with the side opposite that. 71 squared is equal to the sum of the squares of the other two sides, minus twice the product of those two sides, times the cosine of the angle opposite 71, which is C. Once again here, if you try to use the solve feature, the variables embedded inside the trig ratio, it's not going to work in that way. You can still use the solve feature. Okay, but if you do, what you would need to do is let your variable be the entire trig ratio cosine C. Okay, meaning I could do this. If I let this be x here, and I solve for x, so I get 71 squared is equal to 51 squared plus 65 squared minus 2 times 51 times 65. Times x. Again, notice I let my whole cosine C be replaced by x, and then I'm going to solve for x. I didn't put a decimal anywhere, so I'm going to hit the diamond button to get my answer in decimals. Oops. Let me re-enter this. I used the wrong power here. Okay, so if I entered the solve feature, 71 squared is equal to 51 squared plus 65 squared minus 2 times 51 times 65 times x. And I'm solving for x. I'll hit the diamond to put my answer in a decimal form. My expectation is the cosines need to find or fall between -1 and +1. This one does, so 0.269. So x is equal to 0.269. And remember, x was the cosine of c. And so if I want to solve for c, I can take the inverse trig ratio of that value. And so here I'm taking the inverse cosine of this quantity. Again, get rid of my x equals, and I get my angle measure. So 74.38 is my angle C. And once you find your first angle, your problem now becomes an SSA problem, which means you can use the law of sines for it. We already know there's only one triangle that fits this, so you can choose either one. Again, I would always just stay consistent, and I'm going to find the smaller of the two remaining angles next. So here I could use the law of sines to find angle B. So sine of B over the side opposite it, 51, is equal to my known ratio, which is now sine of 74.38 over the side opposite it, 71. Multiply both sides by 51 to get the sine of B alone. I can do my calculations here. So take the sine of this angle that I just found, times 51 and divide by 71. I've already entered a decimal. I get my ratio of 0.692 approximately. And so to calculate B, I can take the inverse sine of that ratio, and that gives me my value. So the inverse sine of this ratio gives me 43.77. So that was angle B. And then my final step is to calculate A by using triangle sum. 180 minus the two angles that I found here and here. Now, you need to be careful on these. Because we're rounding, it is possible that these won't all add up to the value or to a total of 180 degrees. If that's the case, there should be a little bit of leeway on missing by 0.01 type of thing on these. But you can see here, this is going to be 61.85. So 61.85. If you added all three of those together, it is going to be 180. And you can see the 74.38 would be my last one.